All right, let's go. We're simplifying rational expressions today. Normally, I would teach you how to add, subtract, and multiply and divide rational expressions, but we're not going to do that. No, it's a pandemic. If for some reason you found this and it's no longer a pandemic, you can email me and I'll do this example again, but like for now, we're just doing baby level stuff. Okay, which doesn't mean it's easy, which is why we cut out all the adding, subtracting stuff, but I got you. Let's do this. All right. So to simplify, we're going to first factor. Factor is that X puzzle. Just as a reminder, if I have like x squared plus bx plus c, c goes on top, b goes on bottom. And it's what multiplies to get the top, adds to get the bottom. And then it's the two terms become x plus whatever, x plus whatever. So let's just do an example, and then I'll explain the rest of it as we go. So for example, all right, so we're going to factor both top and bottom of this. So I'm going to use my little X puzzles. If you learn this a different way and you're not one of my students, I don't know, get out of here. No, I'm just kidding. Then I'm going to put it over here. Then this is how it works. So negative 12 and negative 4. Negative 12, what multiplies to get negative 12 and adds to get negative 4? Well, I know that 6 times 2 is 12, and 6 and 2 kind of make 4 if I subtract them. So I want this to be a negative 6 and a positive 2 to make a negative 4. I'm going to do the same thing with this other one, which looks kind of weird because there's no value in the middle, but it'll just be negative 4 and 0, which is 2 and negative 2. So what that means is that my, I don't know how to do this the other way. Okay. That means that my expression, by the way, expressions don't have equal signs. This is an expression. So it's going to be x minus 6, x plus 2, and then x plus 2 and x minus 2 on the bottom. Right here, I can restrict my domain because it's just whatever I would divide by, or I can't divide by, basically. So here's our, we love this part. You ready for this? We love this. I can cancel things out here. I can't cancel things out here, by the way. It doesn't, I can't like cancel out the x squareds and cancel out the 4 and I'm left with x minus 12. No. Okay, don't do that. You have to factor. You can't just cancel willy-nilly. You can only cancel factors, not terms. If it's factored and they're multiplied together, you can cancel them. If it's a term and it's added to other stuff, you can't cancel it. Sorry for my cat. Okay, so then this is going to be x minus 6 over x minus 2, and x can't be negative 2 or positive 2. I don't know if you're invested because you saw it roll around down there, but my cat knocked off my thing and like the slidey part got stuck to the outside of it. Now there's water all over my floor, but it's going to be fine. Okay. Once again, this part right here is from both of the things that were on the bottom before. So I can't divide by 0. That's the whole point here. Divide by 0. There's really only 2 rules in math. And we already broke one of them. We can't take the square root of a negative. We can't. And we can't divide by 0. We can't. So that's why this domain is restricted. Both of these things are part of the answer. It's the simplified function and what x can't equal. Okay, let's do another one. All right, once again, I'm going to factor this top. Okay, we're going to do it this way. 30 and negative 11. And then the bottom one here is going to be 0 on top and negative 6 on bottom, which looks weird, but it's okay. I got you. Okay. What multiplies to get 30? 2 times 15. 10 times 3. 5 times 6. 5 times 6. So negative 5 and negative 6. I have the answer over here, but I'm not looking. Okay, and then what multiplies to get 0 and adds to get negative 6? Well, it has to be 0 times something, and then 0 plus negative 6 is negative 6, so that's it. Sorry for the train. Sorry about it. So this is equal to x minus 5, x minus 6 over x times x minus 6. I don't need to write the x plus 0 part. The 0 is like a bonus. I don't care about it. Sorry. Sorry, little guy. So this is x minus 5 over x, and x cannot equal 0. or positive 6. I can also get that from here. It's just like when we solved them back in, I don't know, last unit or the unit before, whatever the heck. No, that was like first trimester. So it's going to be opposites. Opposite of 0 is still 0, but negative 6 becomes positive 6. Okay, let's do another one. Like my stained glass window happening over here. Okay, this one looks different. It does, because I can't factor anything. The key here, though, is that these are already factors. There's no plus, no minus. So this one, I can skip the factor step. So what I'm going to do is I'm only going to focus on one thing that matches at a time. So the 3 and the 9, both the 3 and the 9 can divide by 3. Okay, so I'm going to end up with another fraction, and there's going to be a 3 on the bottom and like a 1 on the top, but we don't really care about the 1 on the top. You know what I mean? Okay, so, and then I look at the x's. If I have 5 x's on top and 1 x on the bottom, do you want me to write this? And 1 x on the bottom, I can cancel one of them out. So I have 4 x's left. The cheaty way to do that is to subtract 5 minus 1 is 4. And then similarly for the y's, if I have 2 y's on top and 3 y's on bottom, I can cancel out 2 of those and I'm left with 1 on the bottom. So this is just a y. Okay, and then I can't divide by 0. And there's 2 variables here, so I'm restricting the domain and the range. Ooh, what if there was 3 variables? What would we call them? TBH? No idea. I should know. What if it's a Z? Is it domain, range, and time or something? I don't want to hurt myself like this. Okay, so that's actually it for me. Oh, but actually, let me do one more. Ta-da! Okay, this one feels like I can't factor it because there's a number in front here, but it's I can take out a greatest common factor of 3x. So if I take out a 3x, I'm figuring out what's left when I would distribute it in. So 3x squared divided by 3x, there's only an x left. And negative 3x divided by 3x is minus 1. And then there's a 6x on the bottom. So now I have factors, and I can cancel out an x. And the 3 and the 6 can both be divided by 3. So I actually end up with x minus 1 over 2, which is a linear function. This is a straight line, but it has a hole in it where x equals 0. All right, that's good enough for me, by golly. This is weird factoring stuff. We might do some more factoring practice in class, if I remember. We'll get there if we do. But otherwise, I hope you have a great day, and I'll see you like in a second in the next video. Bye.